An access control list, with respect to a computer file system, is a list of permissions attached to an object. An ACL specifies which users or system processes are granted access to objects, as well as what operations are allowed on given objects. Each entry in a typical ACL specifies a subject and an operation. For instance, if a file has an ACL that contains, this would give permission to access the file. ACL-based security models. When a subject requests an operation on an object in an ACL-based security model, the operating system first checks the ACL for an applicable entry to decide whether the requested operation is authorized. A key issue in the definition of any ACL-based security model is determining how access control lists are edited, namely which users and processes are granted ACL modification access. Implementations. Many kinds of systems implement ACL, or have a historical implementation. File system ACLs. In the 1990s the ACL and Rbac models were extensively tested and used to administrate file permissions. A file system ACL is a data structure containing entries that specify individual user or group rights to specific system objects such as programs, processes, or files. These entries are known as access control entries in the Microsoft Windows NT, OpenVMS, Unix-like, and Mac OS X operating systems. Each accessible object contains an identifier to its ACL. The privileges or permissions determine specific access rights, such as whether a user can read from, write to, or execute an object. In some implementations, an ACE can control whether or not a user, or group of users, may alter the ACL on an object. Most of the Unix and Unix-like operating systems support POSIX1 ACLs, based on an early POSIX draft that was abandoned. Many of them, for example AIX, FreeBSD, Mac OS X beginning with version 10.4, or Solaris with ZFS file system, support NFS v4 ACLs, which are part of the NFS v4 standard. There are two experimental implementations of NFS v4 ACLs for Linux, NFS v4 ACL support for ext3 file system and recent Acls, which brings NFS v4 ACL support for ext4 file system. Networking ACLs. On some types of proprietary computer hardware, an access control list refers to rules that are applied to port numbers or IP addresses that are available on a host or other layer 3, each with a list of hosts and/or networks permitted to use the service. Although it is additionally possible to configure access control lists based on network domain names, this is generally a questionable idea because individual TCP, UDP, and ICMP packets do not contain domain names. Consequently, the device enforcing the access control list must separately resolve names to numeric addresses. This presents an additional attack surface for an attacker who is seeking to compromise security of the system which the access control list is protecting. Both individual servers as well as routers can have network ACLs. Access control lists can generally be configured to control both inbound and outbound traffic, and in this context they're similar to firewalls. Like firewalls, ACLs are subject to security regulations and standards such as PCI DSS. SQL implementations. ACL algorithms have been ported to SQL and relational database systems. Many modern SQL-based systems, like enterprise resource planning and content management systems, have used ACL model in their administration modules. Comparing with Rbac, the main alternative to the ACL model is the role-based access control model. A minimal Rbac model, RBACM, can be compared with an ACL mechanism, ACLG, where only groups are permitted as entries in the ACL. Barkley showed that RBACM and ACLG are equivalent. In modern SQL implementations, ACL also manage groups and inheritance in a hierarchy of groups. So modern ACLs can express all that Rbac express, and are notably powerful in their ability to express access control policy in terms of the way in which administrators view organizations. For data interchange, and for high-level comparisons, ACL data can be translated to XACML, see also, CACLS, capability-based security, Confused Deputy Problem, DACL, Role-Based Access Control, References. Further reading